Hello guys, welcome back to my YouTube channel. So today we are going to solve problem number 862, shortest sub-array with sum at least k. Okay, so this is a hard level problem, but by the end of this video you guys will find this problem very easy. Okay, so let's read the problem statement first. So we have given an integer array nums and an integer k. We have to return the length of the shortest non-empty sub-array of nums with the sum of at least k. If there is no such subarray, then we have to return -1. Okay, and what is subarray? A subarray is a contiguous part of an array. Okay, so here see this example number 1. Only one element is there, and what we need some at least 1. Okay, so that is possible with just one element. Okay, so if my subarray is like this, then it's fine. Okay, and what is the length of this subarray? 1, so we are turning 1 here. Okay, and here see, uh, in my nums we have elements 1 and 2 and k is equal to 4. So if I consider this whole nums as one subarray, I will not find my sum greater than or equal to k, right? So in this case the result is not possible, right? So we are returning -1 here. Okay, and here in this example, so if I consider this subarray 2 and -1, then I'm getting sum as just 1. Okay, but if I consider this complete as per my subarray, then I am getting sum as 3. Okay, so this is possible. So we are getting our sum is equal to k or greater than k, right? So it is possible. So this is possible with length 3, so that is why output is 3. Okay, so I hope that you guys are clear with the problem statement. Okay, so now here I tried brute force here to solve this problem. So here what I was doing here, I have calculated the length of my nums array, and then I have created one variable found. Okay, and set it to false. Okay, boolean found is to false, and I took one min value as integer dot max value. Then I was just running one loop over all the elements in my nums array one by one. Okay, and I was trying to find I'm inside that I'm running one j loop, and I'm trying to find if my sum becomes at any point of time greater than equal to k. Okay, if it becomes greater than equal to k, then I'm just going to calculate the count. Okay, and I'm setting this found to true and break. Okay, and here I'm just going to update my min value as minimum value. Okay, so in the end I see that 90 out of 98 test cases got passed here, right? And we are getting time limit exceeded error. Okay, because here this loop is running n times and this loop is also running n times, so overall time complexity for this brute force is going to be of n square. So that is why result is not possible. Okay, so simply what I was doing here from here I started, I check all the elements until my sum becomes greater than equal to k. Then from here I started, and then I check from here I started, then I start checking again. Okay, so this was what I was doing here, but this is brute force, so that's why result is not possible, because the constant size is very large, right? So now let's see the better approach for this problem. Okay, so what I'm going to do here, okay, so let's take one example. Let's say that I have these elements in my nums array 2, -1, and we have done 2, we have done 3. Okay, and what we need our k is equal to 6. Okay, k value is given to 6. Okay, so we need sum greater than equal to k. Okay, so and we need to find that particular sub array. Okay, so here what I'm going to do here, I'm going to create one deque. Okay, I'm going to use a monotonic increasing deque. Okay, and why I'm going to use that, so let's see here. Okay, so let's say this is my deque. Okay, so here first thing that I'm going to do, I need a sum greater than equal to 6, right? This is what I need. So here I'm just going to create one prefix sum array. Okay, prefix sum array, and here I'm going to create this prefix sum array of length n plus 1. Okay, so here this is my original array, right? Nums array, right? Let's say this is my nums array. Okay, and this is nothing but 0 index, 1 index, 2 index, and 3 index. Okay, and the length of this one is 4. So I'm going to create one prefix sum array of length 4 plus 1, that is 5. Okay, and here initially all the elements are set to 0 only. Okay, initially this is the case, right? And then after that, if I start from here, initially element is 2, right? So here I'm just going to update it to 2. Okay, so at this index I have stored the prefix sum until my 0. Okay, so here I have stored that at index 1. Okay, so here I am going to say that this is nothing but my index number 0, index number 1, index number 2, index number 3, index number 4. Okay, so until index number 1 I have sum as 2, okay, of this one. Okay, then after that here I'm going to operate 2 plus minus 1, so answer is 1. So here I'm operating 1. Okay, let me use some other pencil here. I'm using 1 here. Okay, and then uh okay, then until here I have to consider sum, so total sum until here is 3. Okay, and so here I'm updating it to 3, and then until here I'm considering the sum, so 2 minus 1, 2, 3. Okay, sum is 6. See, sum is 6. Okay, so this is clear how I'm feeling, right? So prefix sum we are calculating. So here at one index I'm storing the sum until 0. Here at index 2 I am storing the sum until index 1. Here at index 3 I am storing the sum until index 2. Here at index 4 I am storing the sum until index 3. Okay, of all the elements. So simple way to calculate the prefix sum. Okay, simple formula that I'm going to use is prefix sum at index I plus 1, okay, is equal to prefix sum at index I plus nums of I. Okay, this is simple formula. So here this is 0, right? And then I am storing prefix sum at one index, so prefix sum at 1, so I is 0 only initially, right? Prefix sum of 1 is equal to prefix sum 0, which is 0, and nums of 0 is 2. Okay, so I'm getting prefix sum at 1 as 2. Okay, so this is how I'm going to simply calculate. Okay, so prefix sum at 2 I want to calculate, so I will become 1 in that case. So prefix sum at 1, which is 2, and nums of uh, here 1 is minus 1, 2 plus minus 1, so I am getting here 1. Okay, so this is how I'm calculating this prefix sum array. Okay, so I hope that you guys are clear how I'm calculating this prefix sum. Okay, now how I'm going to solve this problem. Okay, so here here um, okay, so initially there is my DQ is empty. Okay, this is my DQ. Okay, my DQ initially it's empty. Okay, DQ is empty. Okay, so initially there is nothing. Okay, so here in the DQ I'm just going to add the indexes. Okay, so here initially you see my prefix sum. Okay, my prefix sum you can, or you can here say that my prefix sum at this index number 0 is 0 only. Okay, initially, so I'm just going to add this element in my DQ. Okay, 0 I have added. Okay, initially DQ is empty, so I don't need to check anything. Okay, so here I have added 0. Okay, all right, then I move to the next index. Okay, index 1. So here I see that sum until here is 2. So what is the sum that I need? I need sum as 6. Okay, so here prefix sum at this index is 2, right? And prefix sum at the first index, here prefix sum at first index. Okay, this index, so prefix sum at this index 0, here is 0 only. So here this value, tell me if it is greater than equal to this 6. No, it is not greater than equal to 6, right? 2 is greater than equal to 6. No, so here this is not greater than equal to 6, so we don't find any subarray yet, right? So this is what I'm checking. So until here sum is still 2, we don't find any subarray. Okay, so then after that I am just going to maintain monotonicity by removing the indices that are useless. Okay, so here 0, and then here I'm just going to check if my DQ is empty. So initially it is not empty, right? Here it's not empty, I have added this 0. Okay, from last time. So here what I'm going to say, here at this position, so prefix sum at this index is 2. I'm going to check this is less than equal to prefix sum at DQ dot peak last at here. Okay, 2 is less than equal to 0. No, not right. So here I'm adding 2. Okay, so let's understand it like this simply. Okay, I will explain this with code later on. So initially prefix sum 0, add that in, add the index. Okay, I am adding this index 0. Okay, then here at this position prefix sum at this index here is still 2. Okay, which is not greater than equal to 6. So here this is not clear. Okay, then after that I have to maintain the monotonicity of my DQ. So here I will see that this sum is increasing continuously. I want the sum to be in increasing order, right? So 0 to just increasing. So here just add the index. So here I'm adding 1. Okay, this is 1 I have added. Okay, then after that I reach here. I reach here. Again, sum becomes here 1. Prefix sum becomes 1. 1 is greater than equal to 6. No, we don't find any subarray yet. Okay. this is done. Now after that I will see here at this position I see that prefix sum at this particular index is 1, which is less than equal to the prefix sum at the last index of my DQ. Prefix sum at 1, you see here. So 1 is less than equal to prefix sum at index 1. Okay, so 2. So 1 is here, it should be 1, and here 1 is less than equal to 2. Yes, this is true. So here see, I am moving like this, starting from 2. If I am seeing, then it will be greater. Okay, if I'm starting from 1, I will see, then it is best. Okay, so why should I need to check from this 2? If from 2 I'm taking the U-turn back to 1 and then again moving forward, so this 2 is useless. Okay, so instead of that, just see from here 1 to 6. Okay, instead of seeing from 2 1 6. Okay, from 2 I'm decreasing now, I don't need this. Okay, so why should I check from 2? Okay, instead of this 1, I'm just going to simply write 2. 2 is nothing but the index. Okay, so this is useless for me. Okay, because this will always increase the length of my root. Okay, the length of subarray, so this is useless. So that's what I am doing here. Okay, now after that I move here. So I see that prefix sum at this index is 3. Okay, 3 is greater than equal to 6. No, so here this is not. And then after that I will see the prefix sum at this index is 3, and this is greater than the prefix sum at the previous index. Okay, so here I'm adding 3. Okay, this is done. Now after that, in the end I will see that prefix sum at this index is 6. Okay, and 6 is greater than equal to k. So in that case, what I'm going to do, I'm going to update my minimum length. Okay, minimum length, I'm going to update that as my minimum length. Initially I'm going to take it as max. Okay, here I'm just going to consider math.min infinity, and here I index. Okay, here I found that na 4 minus dq.poll first. So here I'm removing this element, so 4 minus 0. And okay, so here what is the output that I'm going to get? 4. Okay, so 4 is the output that I'm going to get. Then after that, here I see that prefix sum is greater, so here I'm just going to add 6. Okay, and in the end you see I have covered all the elements, so in the end my output was 4 here, main length. Okay, so this is the case. So here like this only I will get the best output has 6. Okay, so 4 why 4 is the length, right? So here 2 1 1 plus 2 3, 3 plus 3 6. Okay, so all the elements. So now with code you will get a much better idea. Okay, code is going to be very very simple for this one. Okay, if you guys get puzzled here, no issues, just see the code is very simple, only few lines of code. Okay, so here first thing that you need to do here, calculate the length of nums array. Int n is equal to nums dot length. Okay, and then create one prefix sum array. Okay, so this is clear, right? This is simple prefix sum we are calculating, and you know how we are going to calculate this, right? New long n plus 1 size we need to take, and then calculate the prefix sum. So run one loop for int I is equal to 0, I is less than n, I plus plus. Okay, and here prefix sum at index I plus 1 is equal to prefix sum at index I plus nums of I. Okay, this is done. We have calculated the prefix sum here. Then we have to calculate the mean length. Okay, this is what we need in the end. So initially let's take it as the max value of integer dot max underscore value. Okay, then created one dq. All right, and then just run one loop. Okay, inside this we have to remove the indices where the subarray sum is greater than equal to k. Okay, this is first thing that we need to check. Okay, and just one base condition should be while my dq is not empty. While my dq is not empty. Okay, and now here see carefully, prefix sum at that particular index. Okay, if I subtract this from my prefix sum which is at my dq. Okay, which is there at my dq dot peak first index, peak first. Okay, peak first. K should be small. Okay, peak first. Okay, so here if this sum is greater than equal to K. Okay, so let me just maximize this. Okay, if this is greater than equal to K, then in that case, so this is what I'm checking now. So here we get the sum as greater than equal to 6. So what I was doing, so I have to calculate the length now. So sum 6 I have obtained this sum starting from this element. Okay, from this 0. Okay, so that is why at this index sum is this one, at this index sum is 0, so I've subtracted, I get the sum as 6. Okay, so here I'm just going to update my mean length as math dot mean length I minus dq dot poll first. Okay, this is done. Okay, then we have to maintain the monotonicity by removing the indices that are useless. Okay, so that's I have explained as well, right? uh, Here I have explained this route is not better, this is better, right? So starting from 2, if I'm seeing, then it will be greater. Okay, if I'm starting from 1, I will see, then it is best. Okay, so why should I need to check from this 2? If from 2 I'm taking the u-turn back to 1 and then again moving forward, so this 2 is useless. Okay, so instead of that, just see from here 1 to 6. Okay, instead of seeing from 2 1 6. Okay, from 2 I'm decreasing now, I don't need this. Okay, so why should I check from 2? Okay, so that's the main reason why dq node is empty and prefix sum at index I if it is less than equal to prefix sum at dq dot peak last. Okay, that is why I have removed that. Okay, that is why I'm checking this condition. Okay, and here inside this, just do dq dot all last. Okay, and in the end dq dot add last. Okay, this is done, and here in the end just return. Okay, if my mean length is still integer dot max value, integer dot max underscore value, then in that case return -1, otherwise return mean length. That's it. Okay, so now let's run it and see if there are any code issues, then we'll try to fix that. Just control find. Replace all. Okay, now let's run it. Here I removed completely. Okay, dq. Wait, like this now. The mouse is not working. It should be double equal to now here. So the test case has been accepted. Okay, and here let me do one more thing. Here let me add this. What was our example? 2 minus 1, then 2, and here 6 minus 1. Okay, and here let's take k as 6. Okay, let's run it. Okay, so test case got accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.